This topic is finding the area of a trapezoid, rhombus, or kite on the coordinate plane. This first example is finding the area of a trapezoid. And you can always use the formula to find the area of a trapezoid, but if you don't know that, you can divide this into a rectangle and two triangles. Next, if we remember that the x-coordinate comes first in an order of pair, we can identify this point and this point right here. So the x-coordinate, the left and the right of this one right here, is going to be the same as the x-coordinate of this ordered pair, because it's the same distance to the left of the origin right here, the same distance to the left as this point is right here. So it's going to have the same x value, and its y value, that's the up and the down, it has the same y value as this point right here, and its y value is -1. This point over here will have the same x value as the one directly below it because it's the same distance from the y-axis, so it'll be 4. And its y value is going to be the same as this other one because it's the same distance from 0, so it's going to be -1. Now, part of the reason why we identified those points is to determine if these two triangles, this one and this one, are congruent triangles, meaning that they have the exact same area. So we know their height is going to be the same. The question is the base, this distance right here, are these going to be the same length? And it appears that they are, but let's make sure. So this length right here is going to be the difference between -5 and -2. To get from -5 to -2, we would travel 3 units. And this distance right here is going to be the difference between 4 and 7, and we would also travel 3 units. So that does confirm that those two triangles are congruent. Next, we can find the area of one of those triangles. Now, the base of that triangle must be perpendicular to its height. So if the blue part, the 3, is the base, then this red part right here is going to be the height. And that height is the difference between the y-coordinate of this point right here, which is -1, and this point right here, which is -8. Remember, the y-coordinate tells you how far up and down the figure is, or the point is. So we want to know how far apart is -1 and -8, and that is 7 units. So we're going to multiply the base times the height, get 21 square units. But to find the area of a triangle, we need to divide that by 2. So if we divide that by 2, we get 10.5 square units. But I actually really didn't need to divide that by 2 because I needed to double this anyway because I had 2 of these triangles that were congruent. So I could have just left this alone, because now what I'm going to have to do is multiply this by 2, which will get me back to 21 square units. Now I need to find the area of the rectangle. So this green rectangle right here. We know this rectangle has a height of 7, and we want to know what its base is right here. And its base is going to be how far apart its x-coordinates are of these 2 points on the ends. So from -2 to +4, here's -2, here's +4, here's 0. That's going to be 2 plus 4, which is 6 units. So that green rectangle is going to have an area of 7 times 6 units equals 42 square units. And now, lastly, all we need to do is combine the rectangle plus the 2 triangles, which gives us 63 square units. For this one, we have a rhombus, and I'm going to just divide this rhombus into 2 triangles. And the base of these 2 triangles, by the way, are congruent. So I really am only going to need to figure out one of these triangles. The base of the triangle is going to be this, and the height is going to be this, because I want it to be perpendicular to the base. So really all I'm going to really care about is this whole triangle right here. And then after I find its area, I will double it to get the other side. So first of all, let's find the base. Remember, the base is this part right here, this blue part right here. And that's going to be the difference in the y values, because that's the distance up and down. So that's going to be the difference between -6 and positive 2. You probably can just count up again from -6 to 0 to 2. So that's going to be 6 plus 2 units, which would be 8 units. The height, let me make this a different color. Let's make the height right here be green. And the height is going to be the difference between the x coordinates, so the difference between -9 and -4. So how far apart are -9 and -4? And those are 5 units apart. So we can multiply 5 times 8, which is 40. Now, for this red triangle here, we would divide by 2, but honestly, we don't really need to do that because if I divide by 2, I'll get 20, and then I'm just going to have to add another 20 for this side anyway. So 40 units is already my answer, not units, square units, is already the area of this rhombus. And for this last example, we have a kite, and I'm going to divide my kite into 2 triangles. I think I'm just going to go like this and divide it in half. We can see 2 triangles, a top one and a bottom one. And then what I'm going to do is I'm going to make I'm going to call that my base, and I'm going to make this be my height. And I'm only going to worry about, let me shade this. I'm going to only worry about this green triangle because once I get its area, I can just double that area for the bottom one. So this blue height rather is perpendicular to the base. Let's find out the base first. The base is going to be going this direction, left to right. So that'll be the difference between the x values, -5 and +7. Here's -5, here's 0, here's +7. So that would be 5 units plus 7 units, which would be 12 units. The height part, this part right here, this blue part right here, it's perpendicular to the base. That's going to be, because that's up and down, that's going to be the difference between the y values. This y value and this y value. So this time we're at our difference between -3 and +3. That's going to be 3 plus 3, which is 6. Now we need to multiply our base times the height, 12 times 6, which is 72. If we divided that in half, we get 36 for one of the triangles, but we just need to double it for the bottom one, just like in the last example. So I'm not going to bother dividing it. Our answer is going to be 72 square units.